Hi, in this video, we are going to look at multiplication and division of integers, and we're also going to start looking at the order of operations. Specifically, we're going to start off this section by looking at multiplication and division. First, we'll start with models for multiplication of integers. Then we'll discuss the properties of multiplication with integers. We'll divide integers, and we'll look at the order of operations on those integers. First, we have integer multiplication. Looking at the pattern model here, it says we're going to find 3 times 2 using repeated addition. So when we look at multiplication, multiplication is just repeated addition. When I see 3 times -2, it's -2 plus -2 plus -2, which is -6. We have multiplication because it's like a shortcut, so we don't have to write out this big, long, repeated addition every time. We can use the commutative property to find -2 times 3. So -3 times 2 is the same as -2 times 3. Because how would we represent -2 times 3 using repeated addition? That's kind of tricky, right? So if we have -2 times 3, we can say, hey, that's the same as 3 times -2, which means I'm going to say -2 plus -2 plus -2 3 times to get -6. So we can use our commutative property to help us. We can use patterns to find something even more tricky, like -3 times -2. We know that 3 times -2 is -6. 2 times -2 is -4. 1 times -2 is -2. And 0 times -2 is 0. We should know that when you multiply a positive times a negative, you get a negative answer. When you do a negative times a positive, you get a negative answer. If you do a positive times a positive, you get a positive answer. But what happens when you do a negative number times a negative number? Well, in that case, negative times negative gives us a positive number. So you can see here, we have -1 times -2 gives me +2. -2 times -2 gives me +4. -3 times -2 gives me +6. Also represents multiplication visually. Like here we have 3 times 2, which we have 3 groups of 2. You can see that's 6. 3 times -2 would be -6. We can represent that with our charge field type model. We just have negative dashes. So 2 groups of negative, 3 groups of negative, and we can count them up and we get -6 in that case. This is just a way to visually represent, and you can also read about in your notes, a number line model as well. Although students in the past haven't really found a number line to be as helpful when we're doing multiplication. Let's look at our rules for integer multiplication. Look at our rules for integer multiplication. If a and b are both greater than 0, or if they're both less than 0, both of them being the key word, then when you multiply a times b, it's going to end up being a positive answer. It says you'll get the absolute value of a times the absolute value of b. So what's that telling us is when we do a positive times a positive number, we'll get a positive number, like 2 times 3 equals 6. When I do a negative times a negative number, I'll get a positive number, like -2 times -3 equals +6 again. That's a summary of those rules. Whereas if we have one of a or b is less than 0, so if one of these numbers is negative and the other one's positive, then our answer is going to be negative. So that's fancy math speak for saying positive times negative equals negative, and negative times positive equals negative. So if I have 3 times -4, I'll get -12. If I have -2 times +5, I'll get negative 10. One of them is positive times a number times a negative number. The other is a negative number times a positive number. And we always come up with a negative result in that case. We have our properties of integers here for multiplying. When you multiply, the closure property just says when I multiply two numbers, there's only one unique answer I can get. So if I multiply 2 times 3, I'm only going to get 6. There's no other answer I can have. The commutative property says that if I have any two integers, a times b, if I reverse their order, I'll still get the same answer. So 2 times 3 equals 6, but 3 times 2 also equals 6. I can multiply in any order. And the associative says, if I'm multiplying 3 or more numbers, it doesn't matter. 2, 3, 4. Doesn't matter if I multiply 2 times 3 first and then by 4, or if I multiply 3 times 4 first and then by 2. Because I'll have 6 times 4 is 24 on this side. And over there I'll have 2 times 12, which is also 24. I get the same answer either way. The identity property for multiplication, if you take a number and multiply it by itself, so 12 times 1, I still have the same identity. Nothing's changed. I get the same number. 12 times 1 is 12. And then finally, we've mentioned the distributive property, but the distributive property for multiplication over addition says that if you have a number on the outside and then things being added inside of your parentheses, what you're going to do is you're going to take that number on the outside and multiply it by each of the parts of the sum. So in that case, we'll do a times b and we'll add it to a times c. That's the distributive property. And our final property is the zero multiplication property. If I multiply anything by 0, I get 0. 5 million times 0 is 0. As you go into your next page, you'll see just another summary of what we learned about positives and negatives. If I multiply a number by -1, I'll have the negative of that number. If I take a positive times a negative or a negative times a positive, I'll get a negative answer. And when I multiply two negative numbers, as I have negative a times negative b right here, I'll get positive a times b. This is just taking our rules for positives and negative multiplication and just applying them in a more formal format. But if I have two positives multiplied or two negatives multiplied, I'll get a positive result. If I have one positive times one negative, I'll get a negative result. Our distributive property here for multiplication over subtraction of integers, or multiplication over addition of integers, remember we are just taking our number on the outside and we're applying it via multiplication to each number on the inside of the parentheses. Let's practice that. Here we have -3 times x minus 2. We'll take -3 and we'll multiply it by x. And we'll take -3 and we'll multiply it by -2. So I'll have -3x when I do the first set of multiplication here. Now I'm going to take -3 and multiply it by 2. So I have a minus sign as my operator. And then I'll have 2 times -3. So I'll have -3x minus -6. And I know that if I subtract a negative sign, I get a positive. So my final answer here will be -3x plus 6. For today, we are going to skip example B for distributive property, but I'm sure we'll get back to it by the end of the semester. Let's move on to talk about exponents. An exponent is just a power representing repeated multiplication. So we have 2 to the 5th here, and the base is 2. That's the big number. And then the little number up top, the 5 in this case, that's called the exponent. And 2 to the 5th represents 2 times 2 times 2 times 2 times 2. So we're multiplying 2 by itself 5 times. And that's how exponents work. Let's do some examples to make sure we understand that. Here I see 4 multiplied by itself 3 times. So instead of writing 4 times 4 times 4, I can shorthand it writing 4 to the third with my exponents. Here I see 11 multiplied by itself 1, 2, 3, 4, 5, 6, 7 times. So instead of writing out 11 times 11 times 11 times 11 times 11 times 11 times 11, it's a lot quicker to write 11 to the 7th. So that's like a math shorthand, the exponents. To take an exponent and write it in expanded form, we can do these examples. 3 to the 7th is 3 times 3 times 3 times 3 times 3 times 3 times 3. A lot of writing, right? And 12 to the third is 12 times 12 times 12. 12 multiplied by itself 3 times. An important note about exponents is that they only belong to what's directly next to it. And we can see through these examples below that sometimes you'll have something next to your exponent expression. Our first example is negative 3 squared. So the exponent 2 is only next to the 3. We can think of this as negative 1 times 3 squared. Whenever you see a negative in front of something, it really means negative 1 times that expression. So what we're going to do is we're going to figure out what 3 squared is, and 3 squared is 9. So our answer is going to be negative 1 times 9, or negative 9. This next example, the 2, the exponent 2, belongs to what's right next to it. What's right next to it is negative 3 in parentheses. So this means negative 3 times negative 3. Negative times negative is a positive, so we get positive 9 for our answer in this case. In our next example, we have 4 times 2 to the third. The exponent 3 only belongs to the 2. The 4 is being multiplied next door. So it's 4 times 2 to the third. 2 to the third is 2 times 2 times 2, or 8. 8 times 4 is 32. So our answer would be 32. Whereas this example here, we have in parentheses 4 times 2 raised to the third. So the exponent belongs to 4 times 2. So I have to figure out what 4 times 2 is. And 4 times 2 is 8. So I get 8 to the third. And we can use our calculator if we want, but 8 times 8 is 64. And 64 times 8 is 512. Our final operation is integer division, so division. Our definition is if a and b are integers, then when we divide a by b, well, the answer is the unique integer c if it exists, such that a equals b times c. So sometimes you'll see integer division as a divided by b. That's the same thing as saying a over b. So a over b is equal to c, where a is equal to b times c. So if I can multiply any two numbers b and c to get a number a, then that means I could take a and divide it by either of those numbers. So example, if I have 6 is 2 times 3, then we can say that 6 divided by 3 equals 2, or 6 divided by 2 equals 3. If we divide negative numbers, two negative numbers, we'll get a positive result. But if we divide a positive and a negative, then our answer will be negative, much like we had for multiplication. In summary, if I take a positive and divide it by a positive, I'll get a positive result. A positive divided by a negative, I'll get a negative result. A negative divided by a positive, I'll get a a negative result. And if I divide two negative numbers, I'll get a positive. Right now, I'd like you to try just A, B, and C. Pause the video and try A, B, and C. You can skip D through F. So pause the video, try those, and we'll check our answers together. You can see our answers. A is negative 3, B is negative 3, and C is positive 3. You'll see written in pink that I wrote whether it was positive divided by negative, negative divided by positive, or negative over negative, so you can see what type of result you would get. If you'd like to look at the order of operations examples here, you can go to part B or part 2 of this video.